Hello everyone. First of all, thank you to the Fosdem organizers for selecting our project, and thank you also to you for being here for this presentation of SemApps, which will last 50 minutes. My name is Adrian, I'm an agronomist and a friend of the Virtuelle Assembly. I'm a user of SemApps through a project which aims at interconnect agricultural actors in Normandy, France. So, what is SemApps? SemApps is an open-source software project. Its development is coordinated by the Virtuelle Assembly, a French-based non-profit organization bringing together about 50 developers and activists. In a context of strong fragmentation of dynamics in the field of transition, VA aims to develop commons such as digital tools, methodologies, and projects to promote the interconnection of transition movements. SemApps is one of the Virtuelle Assembly's core projects. Its mission is to foster interconnection between communities by creating synergies between their platforms. The project is starting. It should reach maturity during the year 2021. With around 10 first implementations. Its code is released under the Apache 2.0 free license. On this image, different actors, a company, a university, a community, and two people use SemApps and the pair ontology that we are going to present you. Each one of them are autonomous. By sharing same standards in a common language, they can, however, exchange data in a decentralized way. The core team of SemApps is composed of Simon Louvet, Sébastien Rosset, Jeremy Dufresne, Yannick Dutey, Mathilde Savage, Thomas Francart, Pierre Bouvier-Muller, and the one I'm replacing actually, Guillaume Rouillère. Let's talk a bit about the context. The hypothesis that the Virtuelle Assembly is putting forward is that the web and the social structures of our societies suffer from their centralized and siloed architecture. They prevent the logics of interoperability, communication, mutualization, collaboration, which leads to a lack of efficiency of our technical and social systems. We identified 6 main problems that we are going to present. The first one is about online privacy, security, and trust. The cause: social networks centralize all their user data into one platform. The effect: data ownership issues lead to mistrust and fear to engage. The social network operator can see all the data and in order to share it has to own it too. The need: distributed identity, authentication, reputation, trust and search mechanism allowing each actor to keep ownership of the data and to share it with flexible access control rules to any other actor or group of actors in the world. The second problem is the fragmentation. The cause: each social network operates as a silo, specializing in specific data types. The effect: data, interactions, identities, profile and virtual meeting spaces are fragmented. As people need to work with different actors, each using a preferred silo network, each actor's data becomes fragmented over different networks. Each user also needs to register on each application, to have many passwords, to fragment its identity, to duplicate its data, thereby losing information, efficiency, and time. The need: data and identities should easily be linked across the world. Context-bound information. The cause: the meaning of mostly JSON data published by current web services are still context-bound to the services provider and make poor use of linkage, which prevents any mutualized development of application and services. The effect: each web project develops one application with one database, leading to strong inefficiencies. The need: use semantic web standards in order to decontextualize information, making it linkable across website contexts. 4. Lack of interoperability. Cause: each web's 2.0 API is different. The effect: a user must register in the platforms of the different communities he is involved in if he wants to exchange something across them. While a programmer must write different code to interact with each website, even when the basic types of objects they are working with is the same. The hypothesis that the Virtual Assembly is putting forward is that the web and the social structures of our society LDP and standards ontology will generate interoperability and therefore communication, collaboration, and true mutualization. 5. Suboptimal technologies for the development of web applications. The cause: each web application requires strongly entangled code between client and server. The effect: the cost of building web applications cannot be amortized easily, with a lot of duplication of functionalities across platforms. The need: using linked data platform enables generalized accessible web components that could work with any web server across the world, dividing the needed time for developing web application onto many stakeholders. 6. Clash between economical and ethical motivations. The cause: in the current web of massively siloed, centralized platform, the user gets free access to a service in exchange for his data. The effect: value created by the crowd is captured by very few actors. The need: enable people to take back data ownership and the attached value. Our objective is to use open protocols as a way to foster the development of P2P social networks on the web and in real life. This approach should allow us to build much more ethical and efficient systems. At the center of this diagram, we have open protocols, W3C standards, and the solid specifications. Not a company, not a platform, not a technology. We can read this diagram as follows. If the first platform uses these protocols to empower its community, and if the second platform uses these same protocols to empower its own community, then platform 1 and 2 will be interoperable, and communities 1 and 2 will be able to connect, communicate, cooperate, thus generating a network effect, and so on. If the third platform uses these same protocols to empower its own community, then it will be able to interoperate with platforms 1 and 2 and with communities 1 and 2. And the network effect will strengthen and as the ecosystem grows, as the platform pool their code, their resources, and their user communities. At some point, as with the open source movement in its fight against the proprietary software, one can imagine that interoperable and cooperative systems will be more efficient than siloed and competitive systems. Technically, SemApps is based on the Solid specifications, so let's discover the Solid project itself. Solid is a proposed set of conventions and tools for building decentralized social application based on linked data principles. Solid is modular and extensible. It relies as much as possible on existing W3C standards and protocols. This is an international project led by the inventor of the web, Tim Berners-Lee. Solid aims to complete the stack of web standards to enable the development of a distributed, secure, and social web. Solid is a set of specifications related to identity, profiles, authentication, authorization and access control, content representation, reading and writing resources, social web app protocols, recommendation for server implementations, recommendation for client app implementations. These specifications must allow the development of a distributed, secure, and social web.
Hey, I'm Pierre, and together we will dig into the next standard SemApps is using ActivityPub. If you're keen on alternatives to social networks and GAFAM, you might know Mastodon, PeerTube, Funkware. So you probably have heard about the Fediverse and ActivityPub. So a bit of concept first. ActivityPub is a protocol standard for decentralized social networks, which can be also extended to create various kinds of federate apps. So it's quite simple. The standard comes with two different parts, a client-to-server API and a server-to-server API. So the service, the application can decide if it wants to implement only one or both of them. It's not mandatory to implement both. And this decision will just depend on the needs of your project. Also, if you're a front-end developer, you might use the client-to-server API. And if you're focused on the federation part, you will focus on the server-to-server. So what are the ingredients it required? The message itself will be formatted with ActivityPub, and it must be attributed to an ActivityPub actor on the left. The actor must be discoverable via webfinger, and the delivery itself must be cryptographically signed by the actor. So it's quite complex. Let's see a precise example through Mastodon. Mastodon is a part of the Fediverse, for which you have an overview here, and it can talk to PeerTube, GNU Social, Funkware, etc. So first part of the standard is the actor. The actor is a publicly accessible JSON-LD document answering the question who. JSON-LD can be a bit tricky, complicated, but it's also possible to use a simple JSON with a @context attribute. So you see here. So here is what an actor document could look like. The ID must be the URL of the document. And all the URLs have to use HTTPS. It's mandatory for ActivityPub. You need to include an inbox, even if you don't plan receiving messages. This is a Mastodon example. It's a legacy purposes, so Mastodon requires it. The most complicated part of this document is the public key, because it involves cryptography. The LD will, in this case, refer to the actor itself with a fragment, the part after the hash, to identify it. This is because we are not going to host the key in a separate document, but we could. Webfinger, it allows us to ask a website, do you have a user with this username? And receive resource links to the response. So the subject property here consists of the username and the domain you are hosting on. This is how the actor will be stored on a Mastodon server, and how people will be able to mention in the tweets, in the publications. Only one link is required in the Webfinger response, and it's linked to the actor document we previously seen. So the message in ActivityPub consists of two parts: the message itself, the object, and a wrapper that will communicate what's happening with the message, the activity. In our case, it's going to be a create activity. Let's say hello world response in my publication about writing the blog post. With the in reply to property, we are chaining our message to a parent. The content property may contain HTML, although of course it will be sanitized by the receiving servers according to their needs. You see different implementations may find use for a different set of markup, and Mastodon will only keep PBR, I, and span tags, which is specific to Mastodon, obviously. So next question is, how do we send this document over? Where do we send it? And how will Mastodon be able to trust it? Which is HTTP signatures to deliver our message. And we will use a post to the inbox of the person we are replying to. Here the key ID refers to public key of our actor. The header lists the headers that are used for building the signature, and then finally the signature string itself. The order of the header must be the same in plain text, and within the to be signed string, and headers names are always lowercase. Yeah, and that's it for ActivityPub.
SemApps, Solid, and ActivityPub are based on the semantic web, which can also be called linked data. The semantic web is based on a standardized data format called RDF, Resource Description Framework. In the RDF world, all data is expressed as triples composed of a subject, a predicate, and an object. For example, Alice is a member of Virtual Assembly. Let's make the analogy with human languages. They are structured by grammar and vocabulary. RDF can be associated with the grammar of the semantic web. Then, on the basis of RDF, we can define vocabularies called ontologies. Sharing a common language enables communication. The same is true for platforms on the web. By sharing common ontologies, different platforms can speak the same language and therefore communicate. Let's focus now on the pair ontology, which objective is to describe in a common way communities in order to facilitate interoperability and collaboration across communities. The acronym PAIR is for project, actor, ID, and resource. The objective of the pair ontology is to foster the development of pair-to-pair networks that could be called iPair web. Let's focus on the actors category. The concepts of person and organization are linked by a semantic link, meaning is affiliated to. The pair ontology allows us to say the person named Alice is affiliated to the organization named Virtual Assembly. Then we can see the actors can be involved in activities. These activities can be tasks, projects, events. We will therefore be able to say the organization named Virtual Assembly is involved in the project named SemApps. The pair ontology manipulates a number of concepts useful to describe the diversity of human organization, such as people, organization, projects, tasks, events, skills, resources, place, documents, finalities, challenges, team, etc. These concepts are logically and semantically linked all together. We will implement pair into SemApps in order to allow our user communities to interoperate their data and collaborate through the sharing of a common language, a common ontology. The pair ontology is published on the web and freely accessible to those who would like to implement it. It was very important to share this context so that you could understand the challenges of SemApps. Now we will talk more concretely about the technical specificities of the software and its main use cases. The main objectives of SemApps are: develop a semantic toolbox, a linked data management system. Deploy ontologies, functionalities and interfaces according to the needs of user communities. Allow the easiest handling as possible. SemApps will allow to deploy services such as semantic mapping, collaborative knowledge bases, territorial and thematic information systems, decentralized social network, business applications. SemApps is ontology-driven, interoperable. It allows complex requests, collaborative editing, authentication and access control. It is highly extensible. The first features we are developing are knowledge base, directory, agenda, project management, marketplace, social networks. SemApps is composed of 3 layers: the triple store, the middleware, the app. Middlewares are interoperable, and apps can interact with different middlewares. SemApps middleware is based on the following protocols: Link Data Platform, Sparkle, OWL, WebID, WebICL, Shackle, ActivityPub. SemApps middleware is based with Node.js. It is based on the microservices architecture we use for that molecular.js. This allows you to use only the services you need. For instance, the triple store, the LDP, the Sparkle endpoint, and the WebID services. You can also add specific services, for instance, the ActivityPub services, or other like a mailer, webhook, or push notification services. We also develop connectors to facilitate the user of LDP, Sparkle, and ActivityPub protocols on the interface side. We started developing connectors for Starting Blocks, LDFlex, Redux, and React Admin. We try to develop SemApps according to 8 conception principles: interoperability, modularity, genericity, adaptability, scalability, accessibility, opening, and user-friendliness. Going back to the beginning of the presentation, we hope you do now understand this scheme, which show one of the results of the implementation of our work. We will now move on to the demos. The first one is about a project called Archipelago. It is a SemApps use case for which we have implemented the pair ontology.
So I'm going to present you some demos about SemApps. My name is Guillaume, and I'm going to first show you this instance of SemApps that we deployed for an organization that we are part of with the team of SemApps. This organization is called Virtuelle Assemblée, and so as you can see, this is my profile on this instance of SemApps. I'm also part of another organization that is called Transition Pathways. It's an organization for which we are going to implement another instance of SemApps. As you can see, SemApps allows to describe organizations and their context. For example, here we can see that Transition Pathways has members, and among these members there is myself. This interface is based on React Admin, a framework that is developed by Marmelab, a French organization. And so we use it for different implementations, like another one which is called Passerelle Normandie. I'm currently in Normandy, and this is a place where lives also Adrian, that presented the first part of this presentation. We develop also another instance for an ecosystem based in Paris, which is called Grand Voisin, that gathers around 80 organizations. This interface is one interface, but we could use SemApps with other interfaces. For example, we can deploy interfaces in graph, like Flowdio that Yannick will present you a bit more just after. But we could also use other interfaces, like the interfaces based on web components that are developing our friends from Starting Blocks. For this demo, we are going to use an instance of SemApps that we are developing for the Troy University of Technology. This instance aims to make a semantic mapping of the organizations which are involved in the renewable energies domain. So we have, for the moment, 5 concepts. The first one is organizations. Then we have types of organization, event, place, and scene. If we click on each one of them, we have like a list of each kind of concept. Okay. Which is interesting with SemApps is that we are going to follow some semantic links. For example, if we click on Virtual Assembly, we are going to be able to follow a link that is normally named as partner. So, for example, we are going to read this interface as follows: Virtual Assembly has partners, data player, Assemblée Virtuelle has partner, Fabrique des Énergies, and so on. So it's not just an HTTP link, it's a semantic link, and so we can explore the graph of concepts that are semantically linked by semantic relations. For example, if we click on Praxener, we can see a description of Praxener and also identify some links that contextualize this Praxener node. For example, we can see that Praxener will participates to a residence seminar, which is called Résidence de la Fabrique des Énergies à Prats de Mollio. And we can also identify that other organizations will participate to this meeting. Okay, this is the basis of this interface. We could also search some stuffs, but there is a little bug right now, and we can finally create some actor. We could create an organization like Interrupt. We will present Interrupt just after, and add some data, for example, a short description, a longer description. We could add a place, a kind of organization, for example, entreprise, business, company in French. Some partners, for example, Starting Blocks, and some themes, système d'information or solid. Okay, and like that we can create a new data. SemApps is a collaborative linked data management system. So for the moment on this instance there is no authentication or access control, but on others instances, for example on Passerelle Normandie, we have here an authentication, also on Archipelago. And the objective will be to allow everybody to contribute together to this collaborative knowledge base. Okay, maybe it's sufficient. If you want to go further, we have a website which is called semaps.org. Below you will find our GitHub here, our matrix chat here, and you can also see the team, the governance, and some documentation around our project. And here you will have other tutorials to discover and maybe install or contribute to SemApps. Thank you all, and see you soon.
I'm really happy to give you a quick overview of SparNatural. SparNatural is a tool which has built our friend Thomas Francard. He lives also in France. He's a friend of Assemblée Virtuelle. And he has developed this little application, which is a natural way, a visual way to build Sparkle queries. Those Sparkle requests, as you can see them on the right of the screen. Oh, I have a bigger window here. On the left is the concept and the information you feed, which will build the Sparkle request. So here you see that I'm looking for an artwork. It's gonna start again. I know it's in a museum in France. It's Le Louvre. It has been painted by a person, Léonard de Vinci, and also Michelangelo. And I know approximately the date it has been painted, after 15,000. On the below the screen, we see the result, and I can directly click to the Wikipedia resource. Here, SparNatural is connected to Wikipedia. We already connected to SemApps. Unfortunately, the website is KO today. But hopefully in a couple of days it will be back again, and you can see it by yourself.
Hi, welcome to Flodio project. The aim of Flodio is first, to display semantic data in a network graph. Secondly, to help user to navigate easily into the graph using the flood concept. But what is a flood? Flood means fluid, linked, open data. It allows you to visualize data in a graph mode and in a page mode. For example, this interface is a cartography of SemApps data for the virtual assembly network. We can associate all the class of permetology with colors and easily display actor, project, organization, whatever. But when you look at the network, it's really hard to analyze which nodes are linked with other. We are lost. Thanks to flood concept, you will be able to concentrate yourself on a node and its neighbor. Let's see how does it work. When you click on the flood, the node opens and display all its concept information. So you can easily read in a page mode all neighbors grouped by class and colors. When you click on the neighbors, you can navigate into the graph, jumping from flood to flood. Each time, the new open node takes the center of the screen. You can also search a node into the graph. You can pan or zoom. You can make a focus on a specific node. You can change the focus on another node and return to the global network. You can also filter using class or properties. Example, if you don't want to see people, you can unselect person class. So thank very much to SemApps team for developing this open source, library and distributed semantic server. I'm very happy to contribute to this project, and I like parentology.
I hope the demos illustrated concretely our work. As you can see, SemApps is a young project. We realized the proof of concept in 2016. The development of the new version started just over a year ago. So far, we have laid the foundation for the project. We have several sub-projects in progress, among which, at the core level, set up ACL rights, be able to link to SemApps instance, view user activities with ActivityPub, view the history of a resource, allow to create solid pods with SemApps, advanced search on SPAR Natural, have a completion on Wikidata. For Archipelago, fully integrate the new version of pair register for an event, reserve a location integrating Hubble, Solid plus XMPP chat, which Alice will present later on, interoperate SemApps with Mastodon, PeerTube, and the Fediverse. At the interface level, view data in graphs, view data on a map, view data on a calendar, display personalized new feeds with ActivityPub. As SemApps matures, we are beginning to structure its business development. In this perspective, we are partnering with data players, a company close to the Virtuelle Assembly, which is the first one to bring SemApps to market. Our first clients are municipalities like Prats de Mollo, universities like Technical University of Troyes, institutions like ADEME, the French Agency for Ecological Transition, and the FabMob, cooperative like La COP des Territoires, which I belong to, associations such as Chemin de la Transition, Global Low-Tech or Data Food Consortium.
Hi, I'm Alice, Community Animator for the Virtuelle Assembly and Starting Blocks, and I'm glad to contribute to this video by introducing you the Solid ecosystem.
As we said before, Solid is a project to reappropriate the web by standardizing APIs. It's a set of specifications that allow interoperability and give power back to the user for a more efficient and democratic web. The Solid community is worldwide. The presentation of the ecosystem that we will try here is by no means exhaustive. We will only focus on few actors in order to give you a sample of the diversity of actors interested in Solid and their use case. Inrupt is the American company that Tim Berners-Lee set up to develop the economic system of the Solid project. Inrupt is interested in the medical files, banking, and more. A first use case interesting to share is the adoption of Solid at the BBC. The goal is to develop user-centric and consent-based content recommendation with Solid. Imagine what your BBC News feed would look like if it could be customized with historical data from other platforms such as Netflix without owning it. Another example is NatWest, a UK bank that also works with Inrupt to streamline digital interaction associated with customer life moments, such as name change at a wedding or registration of a new business through interoperability. Inrupt is the largest and most active company on the Solid project. Starting Blocks is a cooperative that develops an open source technology in order to quickly build Solid applications at lower cost and with the least possible skills. As a cooperative, we strongly believe in community logic and the decentralization of power through the reappropriation of our digital tools. For us, open source is central and radical because we want to make the development and the use of Solid specification as easy as possible. This is the reason why all our productions are under MIT license. We believe that this fight for the reappropriation of the web is a major societal issue. That's why our goal is to drastically reduce the development cost of application to allow greatest number of people to regain control of their digital tools. Our secret sauce is a marriage of web component with Solid. We believe that these two standards have for us the vocation to work together. Indeed, solid standards allow us to reuse a component without having to readapt it to a new data format. Our first use case has been to equip the freelance community we come from, HappyDev. HappyDev is a freelance collective that actually composed of several small collectives that wanted to work together and share their networked effect without losing their autonomy. It's for HappyDev that Starting Blocks developed Hubble, a federated application that includes a chat, a job board, and a skill directory. About 30 collectives are already federated with the Hubble instance of Starting Blocks. Contact us if you want to visit us there. Another use case we have is a European trade union. Trade unions are independent entities that have difficulties to federate and to circulate information in a fluid way. We have developed a federated application for them that include collaborative intelligence tools, decision-making tools, event sharing, and we have taken over the Hubble directory as well. The objective is to improve cooperation between unions to enable them to unite their strength while maintaining their autonomy. We would be very happy to introduce you to our techno and to share our thoughts with you. Do not hesitate to send us a mail at salut@startingblocks.com.
Hello everyone, I'm Quentin, co-founder of Data Village, a personal data science company based in Belgium, and our mission is to unlock the value of personal data for both the organizations and their consumers according to three immutable values. The first is people control, the second is privacy, and the last but not least is full transparency. Most of us daily use digital services, which means that every day we create a stream of online activities. These are our data. And this is an ever-growing database of personal information. However, the data economy model of today is wrong. The data is locked, and the market is also locked, and organizations are pushed to collect more and more data. Personal data is spread and duplicated, making it impossible for people to keep control. On the other hand, the interest of organizations to use personal data is growing, especially when it comes to hyper-personalization, augmented experiences, insights, surveys, and so on. Now, imagine we shift this model, a new model in which consumers could get a view of all their data and control them. Imagine that as an organization, you could just pick and choose this data and extract insights in a minute, with full privacy and without the burden of managing that data. We make it a reality by allowing the consumers to create and control their own digital twins, meaning a virtual representation of themselves based on all the data they create on a daily basis. Then, organizations can use our so-called data passport to query their consumers' digital twins and acquire the insights they need in order to improve their digital user experiences and be able to reach the level of personalization of the internet giants. Along with the data passport, organizations can use our personal AI data cage, which is a confidential computing environment to perform AI data enrichment and matchmaking between their products and any personal data to extract derived data without breaking privacy. Our decentralized technology can serve many different sectors and help solve challenges such as better access to information, better health, better finance management, or mobility, among many others. We are Data Village. Thank you for your attention, and don't hesitate to reach out at contact@datavillage.me. Thank you.
Hey everyone, my name is Joep Meinertsma and I'm the CEO of Ontalla. Ontalla is a software company located in the Netherlands that focuses on building stuff with linked data. We've got an e-democracy platform called Argu, which is all about civic engagement. And the next year we'll be working a lot on Solid projects. The first one will be the DexPod. This is a Solid server built with Ruby on Rails. It's currently in development, but it will be open sourced in March 2021. Solid Search is our next project. This is going to be a search engine plus UI, which is modular and designed to be compatible with various Solid implementations, including the community server. This is expected to be released in the last quarter of this year. And the third project is data deals and payments, which is all about making machine-readable agreements between people who share data and who use data, and enable that process to be monetized, powered by Solid. This is also expected to be released in the final quarter of this year. If you got any questions or want to just talk about Solid stuff, get in touch. Bye!
Thank you for your attention. As you see, we need some contributor to popularize our subject. Hope you've liked this video and our authenticity. Let's get in touch.